Hey, g'day, it's Prezzo. I'm back in the workshop today and got some new stickers. Let's get them up. Okay, this first sticker here came all the way from Charlotte in North Carolina, and the owner of the channel is John Carell. In Australia we'd refer to him as a petrol head or a rev head, but yeah, he's into cars, and I'll put his Instagram link down below there, and that way you can find his YouTube channel as well. Now this one here came from England, and the owner of this channel is Nigel. Now you may have seen some of his videos if you're watching any of mine, but Nigel has just finished up on a build of a tiny little Wilton bullet vise copy, and it's all done in his home workshop, and it's worth checking out because what he's been able to create with a modest workshop is pretty sensational. So thanks Nigel, honoured to have your sticker up on my board here. Now, this next one came from a company in Melbourne, and they're not a sponsor. I own a lot of tools that I've purchased from Eccentric Engineering, and I'm totally happy with them. That's why I'm happy to promote it here. But the thing I like about Eccentric Engineering is that they're a Melbourne-based company and they're still manufacturing. Now, a lot of Australian manufacturing businesses sort of went away because of globalisation, but Gary's still making high-quality tools, and they're reasonably priced, and they're well thought out, well designed. So I'll put his link in the description below, and if you've seen the diamond tool holders that I use on my Colchester lathe, that's where I got them from. And he also sells the Tornado freehand turning system. And I recently bought another accessory for that, and he was happy to send me the sticker along with that tool that I bought. So yeah, check him out. Okay, before we get started today, just a little bit of news. I recently got back from my holiday to Tasmania. We were there for about 3 and a bit weeks, and it was absolutely awesome. The reason you go to Tasmania is to see the wildlife and the wilderness. Now, it's not Paris, New York or London. That's not why you go. And here's just a sample of some of the things that we saw and some of the animals that we were able to see. And the wombats were an animal that my wife and I have not seen in the wild. We've been married 37 years, and since we've been together we've never seen a wild wombat. And we went over to Maria Island and they were everywhere. You just about beat them off with a stick toward the end of the day. But the thing about Maria Island is that there are no cars, no roads. And sadly, a lot of wombats end up as roadkill. But because of the remote location, the fact that it's an island and there are no feral animals there, there are wombats everywhere. So that was great. Now also, while we're in Tasmania, I caught up with Craig. Now Craig runs his own YouTube channel called Craig's Workshop. Here's his sticker up on the board. And he lives in Hobart, so we're able to go around and see him. And also his mate Bill. Now Craig's workshop is under his house, and he's recently moved to this new house, and he's still building the workshop, but it's going to be absolutely fantastic when it's done. I think he's done a video or several videos on the development of that workshop, so check it out. Now his mate Bill was there. Now Bill's been a commenter on my videos for a long time, but I've never met him. His YouTube handle is Bill Baggins, but that's not his real name, but he is Bill. And Bill is thinking about starting his own YouTube channel, and he should, because he is the most incredible knife maker. Now he gave me this as a gift, and it's absolutely beautiful and wickedly, wickedly sharp. And I wish I could show you the level of detail in this thing, because it really is beautiful. So thanks very much, Bill. I know he wants me to use it, and I don't know, maybe I will, but for the moment it's living in a glass case in my dining room because it's so beautifully made. So thanks very much. Now, I had a friend of mine give me a large 10-inch rotary table. Now this is something I've been wanting for a long time, and there have been a number of projects where I could have used it, and I've had to make do with other techniques, but now that I've got that, it's going to be a really, really useful addition for the Bridgeport mill. And do you like my t-shirt? Now it turns out you can get these custom made. It costs about $30. You send them the artwork, they print it on the shirt and send it back to you. So wait till you see the one that I got for the Bridgeport. That'll be coming up soon. But if anybody wants the artwork for the Colchester logo, just let me know, I can send it to you. and you might want to get your own shirt done. Now, what else? Now, we're working on the Titan engine today, and in the last video I lapped the crankshaft to the brass bush or the bronze bush inside the crankcase. And I think when I wound up that video I said that it was a little bit tight, but I've since fixed that. Now, a lot of people gave me a lot of good advice, but as it turned out I'd already fixed it by the time I published that video. And part of the problem is that it's very, very hard to lap up to a shoulder. So that's the lap that I used, and you really need to overrun the lap off either end of the shaft. But with the shoulder there you can't do that. So it's just a fraction tight at that end. And when I say a fraction, I mean microns. So it didn't need much. It didn't have to be oversized by much in order for that to bind. But just a little bit of running in the lathe with some light oil and just working it backwards and forwards, it fixed it. So still a tiny bit tight, but I think that'll get resolved as we go along. So we're going to be working on the back cover for the crankcase today, and we'll see some close-ups of that in a minute. I'm going to use this as my pointer for this next bit of video, but this is a little bit of the detail on Bill's knife, and I don't know if you can see that little etching there with his initial, and just the finish on the steel is absolutely beautiful. Okay, here's our casting. This is the same material that the crankcase is made of, so it's tens alloy, machines really nicely, quite easy to work with. Here's the drawing of the finished part, and you may be able to see that there are a pattern of holes we need to drill in that casting, and I'll do all of that on the CNC mill. But other than that, it's just some straightforward turning and a little bit of milling. Now, a lot of people ask why there were no lugs on the side of the crankcase to attach the engine to the aircraft. And the reason for that is that we're using this casting as our bulkhead mount. So there will be 3 holes drilled in these 3 corners here. So 1, 2, 3. And they will be through holes, so we can use wood screws to attach the engine to a wooden bulkhead. This back of the cover will be bored out, mainly to lighten it. And there will be a pattern of 4 holes drilled around the bore, and they will be through holes, and they'll be threaded into 4 holes in the back of the crankcase itself. Now, this large protrusion that fits inside the crankcase is there to prevent the crankshaft from sliding backwards and forwards while the engine is running. Also keeps the connecting rod on the end of the crank pin. That's the only way that the connecting rod is attached. There's no screw or anything like that to fix it on there. And this protrusion also helps to reduce the volume of that crankcase. Now, with a 2-stroke engine, it's really important that this back cover is absolutely gas tight. In various points of the 2-stroke cycle, you need to be able to pressurize this volume inside the crankcase, and if there are any air leaks there at all, the engine won't run, or it won't run very efficiently. So we've got to get a dead flat finish on this back surface of the crankcase and on this section of the casting here. So yeah, let's stop talking about it, go and do it. That's still way oversized, but that's what the instructions say to do, to leave this diameter oversized. Then we're going to set the position of this face and then machine this face off to the correct length. Okay, we're going to cut this diameter now to be a couple of thou smaller than the bore of the crankcase. that is it. Well, at least that face anyway. So that protrusion there fits into the back of the crankcase, and if we look down inside you can just see the crank pin, and there's a little bit of clearance there, but don't forget the prop driver is what fixes the crankshaft in place really. So there is a bit of float there at the moment, but that will disappear later on. Put a strip of copper in here in the jaws of the chuck just to protect that machine surface, because it is quite soft. And we're just going to grip that. Doesn't really need to be set up in a 4-jaw for this. Alright, we're just going to machine that flat and get that to the correct thickness, which is around about 1/4 of an inch. Pretty close to the correct size already. That's it. Okay, now we've got to bore out the back of this. Now it's got to be absolutely careful we don't drill right through. So the depth of that counterbore has to be between 15.74 and 16 millimeters, around about 5/8 of an inch, and I've only drilled that 14 deep. That's to the tip of the drill bit, right to the point, and then we'll use a boring bar to get a flat bottom and bring it out to the correct diameter. Okay, we're about 2 millimeters off our correct diameter, but a long way short of the correct depth. So this light boring bar is a bit dull and got a lot of chatter, so we'll change out to something that will cut better at that depth. Now there it is. Now this edge around here can be cleaned up on a belt sander or just with the file, but we've got a bit of milling to do up on the top here, just so it clears the piston at the bottom dead center. So just a little flat needs to be machined there, and then we'll drill our hole pattern and I'll clean all this up later. This is the setup I'm using to do this little flat on the top of this protrusion that fits inside the crankcase. Now that provides clearance for the piston as it descends to bottom dead center. In the construction note it actually says to hold this part vertical in the vise, and machine the flat down in Z that way. Machine the flat down in Z that way. But I flipped it so that we got the flat surface on the top of the casting against the jaw of the vise. Just makes it easier to align the flat really. It's only a really light cut. I think we're going 300 thou deep in Z and 60 thou in Y. Okay, I'll just deburr that and head over to the CNC. Okay, just probed the center of that bore there. As you can see, I got the part set up in the vise here with this back edge here registering against the fixed jaw. And what we're going to do now is go ahead and drill the pattern of holes. Now in the construction notes it says to use a series of drill jigs to drill both this part and the crankcase, but I've got a CNC mill and it's ideal for doing this sort of work. So I've done a G-code which will initially just spot drill all 7 holes. 3 have to be the through holes, and then 4 of them will be counterbored for a socket head screw. So we'll do this one, and then we're going to set up the crankcase and use the same G-code to drill the 4 holes for the crankcase, and we'll omit those 3 at the corners. Okay, so there's the 7 holes that spotted through. I'm going to drill those as clearance holes now, all 7 of them, and then we'll come back and we'll counterbore the 4 for the crankcase. Okay, this is a number 28 drill bit. Just going to set my Z here, and we're going to drill right through this time. So set Z. So these are the socket head screws we'll be using to mount this casting on the back of the crankcase, and we need a counterbore now. I think it's 250 diameter, 250 thou, and 156 thou deep. Oh well, because I'm a complete chicken, I've already done a dry run of this, just to be sure. So let's go ahead and do these now. Alrighty, so we'll take that out and deburr it and have a look. Now I'll need to do the other side there too, but this will give you an idea. So there's our socket head screw. And what I'll do now is get all this cleaned up around the outside edge here and polish it. And then we'll get on to do the crankcase. Well, there it is, all cleaned up. I just ran over that with a red Scotch-Brite pad, and I've done the edges with a fine belt on the belt sander, and then finished up with a Scotch-Brite wheel. And I've countersunk all of the holes, front and back. That looks good. So the next step is to do the crankcase, but we're running out of time, so we'll do that tomorrow. Check in then. Okay, this is the setup that I've got for drilling the crankcase. Now, I've just probed the center of that crankcase bore there. You saw that happen yesterday. And I've got the center position of that crankcase now set as my origin. And then I use the same G-code, or at least the edited G-code that I had yesterday, to position the spindle over each of the 4 lug positions. And I'm going to drill those to depth using the quill. So I don't want to drive the drill bit down under power. So in order to position the casting, what I've got is an angle plate. It's bolted down to the bed of the mill with a single M10 thread. And that's because we're just positioning this part. We're not putting any sideways or lateral force on the part. And then I've got a single M10 stud through the back of the angle plate all the way into the bore of the crankcase. Now, inside the bore of the crankcase, I've got a big chunk of PVC that I used for another operation when I was making the crankcase, and that's come in handy for holding that stud. So it's got a single M10 threaded hole in the center of the PVC, and I can snug everything up, tighten it up against the face of the angle plate, and then the casting sitting down hard on the bed of the mill or the table. So that holds everything accurately in position. So we're going to go ahead now and drill those 4 holes, and then they've got to be tapped. Now the depth of the drill hole is 3/8 of an inch, or 9.525 millimeters. That's symmetric equivalent. And then we're going to tap those. I think it's, let me see. So that's 6x32 UNC. Bought those especially for this job. So let's go ahead and do that now. So I'm just doing a bit of a sanity check here. I've moved the spindle to the first location, and I can put the casting in there and then lower the drill bit and satisfy myself that I've got that that I've got it right. Yeah, don't want to mess this up. So I'm just going to go around now and spot drill all 4 positions, and then go back and drill the tapping sides, and then we'll tap. Rightio, I was screwed up there. I didn't get the footage of spot drilling those 4 holes, but you get the idea. So what I'm doing is I'm running the G-code in single step mode, and then when I get over the location I just lower that quill by hand. And what we're about to do now is drill the tapping size for the thread that we need. And I don't have a depth stop on my quill, but I have got a micrometer dial. So I've set that to 0 at that point there where the drill bit is just going to enter the center drill hole, and then we'll drill down to roughly 9.5 millimeters. Okay, so that's the first one, and yeah, it didn't break through on the back here, so that's good. Let's do the next one. So we move back to our first position again. We're just going to put the tap in there. This is an intermediate tap. I think the taper tap is going to bottom out before it starts to cut too many threads. So we'll see how this goes. These taps are brand new. And I'm just going to get each tap started and I'll take everything apart, and I'm going to finish this off by hand. I think you get a better feel for it if you've got the part in your hand and you're using the tap with the other hand. You sort of get a sensation of how much load you're putting on that tap. But this is gummy material, and I'm absolutely terrified that I will break the tap in this casting. So I've got a few threads in there now. I'll move to the next position. And we're just going to keep doing that. And I'm using WD-40 to lubricate everything here. I often watch Joe Piezinski doing this without a care in the world. It scares the living daylights out of me. Okay, that's enough. Let's get this out now, and I'll finish this off by hand. I probably won't show you that. Well, I got one screw fitted in there. Unfortunately, these socket head screws are just a fraction too long. So possibly because I can't get the tap to bottom right out. It won't cut threads all the way to the bottom of the hole. It's just physically not possible. So this one here, when it drives home, it's still got about 1.5 millimeters to go. So I'm going to shorten the screws, and I'll show you the time-honoured method for shortening screws. And here it is. I'm pretty sure you can guess what happens next. Well, Robin Wren said he would have a fit, but it works. Just don't forget to run this against a wire wheel as well, because it does raise a burr on the end of the thread there, and it will chew out the matching thread in the part. So there's that casting all attached now, and the socket head screws are down below that surface, so that's good. There's going to be a gasket between these two surfaces later on, and that's going to give us that pressure tight seal in the crankcase. And if you look inside there, you can see that the crankshaft has a little tiny bit of play, but that will take up later on when we fit the prop driver at this end here. But everything's sort of rotating nice and smoothly at this stage, so really happy with that. There's absolutely no play between that crankshaft and the bushing, which is what I was after really. It's got to be that way. Anyway, let's have a look at the next steps. So in the next episode, we're going to start work on the cylinder liner and the cylinder head. Now the liner is supplied as a piece of seamless steel tube, fairly high grade steel, and the cylinder head is the same alloy that the other two castings are made from. So in that episode, we're just going to do the preliminary machining on these parts. There are some other operations that need to be done at a later stage. And the liner should be just like a sliding fit down inside the crankcase itself, and there will be some cooling fins that are shrunk onto that part at a later stage. But that's coming up, so tune in for that. Hope you enjoyed today's episode. It was a fairly low stress part. I think the part that freaked me out the most was doing all that drilling to make sure that was all going to line up when it went together, but it did, so that's good. So that's it. I'm going to leave you with some footage of some cute little birdies that we saw in our Queensland silver wattle a while ago. They were chewing on the pods and eating those and enjoying them, so check them out. And join me again for the next episode. It's Prezzo signing out. Cheers.